Hello, algebra kids. 9.1, multiplying and dividing square roots. This is it for chapter 9. Look at this. We're flying through these chapters, aren't we? So I know you guys are working hard. Keep at it. Keep going with it. Very proud of you. Don't lose hope. Don't lose faith. Stay forward thinking. Stay encouraging. Encourage one another. Encourage yourself. Encourage your family, and you'll do all right. So I'm proud of you all already with what you've accomplished and what you've done. So just keep up the good work. A few properties of radicals. We're probably going to barely get halfway through what this lesson really is. But just give you a little introduction into it. You'll see stuff that we did in 9.0 is going to come back and play in here as well. So the first thing is the exploration I want to talk about is the square root of 36 plus the square root of 64. Does that equal the square root of 36 plus 64? And if you add those together, these two, you'd find they do not equal. Okay? So the square root of 36 is 6, and the square root of 64 is 8. 36 plus 64 is 100, so that would be the square root of 100, which is 10. So 6 plus 8 does not equal 10. So no. You can't combine them. Okay? So no, you can't combine them. So if you're adding them, you can't just put the square root over the whole thing. That is not equal. Same thing here. If you have the square root of two things that are added, you can't split it up like this. Not with addition. Now with multiplication, it does work. Square root of 4 is 2. Square root of 9 is 3. 2 times 3 is 6. Square root of 4 times 9, that would be square root of 36, and that is 6. Those are equal. So yes, you can do this. Okay? The two sides are equal to each other. Because square roots are based in multiplication. The square root of 4 is 2 times 2. Okay? And so this is just another multiplication sign, so you can do that. Subtraction, do you think this would work? That's 8 minus 6, that is 2. This is 64 minus 36. Oops. Should have done it in my head by then. Square root of 28. And that does not equal, the square root of 28 does not equal 2. Okay, that's going to be a little over 5. Square root of 25 is 5, so a little over 5. So, if you're subtracting two things, you cannot, that is bad doing that step right there, or the other way. Okay, division on the other hand does work. Square root of 100 over square root of 4, so that would be 10 over 2, which is 5. Well, 100 over 4 is 25, the square root of 25, which is 5. So, yes, this does work. So, multiplication, division, you can split that square root up. That house can move around. Addition, subtraction, it cannot. Okay, and that's the main thing I want you to do today. Okay, be able to understand when can you split it up, when can't you. Okay, 277. So, here's your basic steps. This is what we looked at in the last lesson. Square root of 9 times 5 is the square root of 9 times square root of 5, which is 3 root 5. Square root of 9 is 3. Okay, and 9 would have, we did the factor trees, 9 would have 2 3s there. So you have a pair of 3s and you have a 5 left over. Okay. So here, to add or subtract radicals, radicals are a fancy name for square roots, but they include cube roots and fourth roots. You must have the same numbers inside the house. Okay, so to add or subtract radicals, you must have the same numbers inside the house. So if I had 2 root 3 minus 5 root 2 plus 8 root 3, okay, these two will go together because they have root 3s. Think of this as 2x minus 5y plus 8x. These are just labels. You have 2 root 3s. It's kind of like you have 2 apples, 5 oranges, and 8 apples. Well, the apples you can add together. The oranges you can't. So 2x plus minus 5y plus 8x. It's the same idea. So this would be 2 plus 8. We're going to take that times the square root of 3. And then the minus 5 root 2 just hangs out there. So you get 10 root 3 minus 5 root 2. Okay. Now again, sometimes you have to reduce these. what if we had the square root of 8 plus square root of 18? Okay, square root of 8 plus the square root of 18. And you're like, oh, those aren't the same. You can't do anything. Hold your horses just a little bit. Square root of 8, if we factor it down, we have 4 and a 2, we have a 2 and a 2. We have a pair of 2's there. Okay, 4, 2, and we have a 2 left over. So square root of 8 simplifies into 2 root 2. 18 is 9 times 2, which gives us a pair of 3's with a 2 left over. So that's plus 3 root 2. So 2 root 2 plus 3 root 2 is 5 root 2. So yes, you can combine them in that case, but you have to simplify them first. Okay. Division. So square root of 3/4, you can break it up into the square root of 3 over the square root of 4, which would be root 3 over 2. Your final answer, the denominator, must be a whole number. Okay, denominator must be a whole number. So no square roots in the bottom. And this is an old-fashioned rule that goes back to before they had calculators, but we got calculators now. But I'm going to tell you, share with you what it is and what they want on the assignment. It's called rationalizing the denominator. Rationalize the denominator. Denominator is 1. And rationalize doesn't mean you're going to argue with it and make it rational, but you are going to make it rational. Okay? A square root like the square root of 3 is irrational. So they want a rational number like 2 down there. They don't want the square root of 5 or the square root of 8. This one is okay. I'm not saying this is wrong, but this is okay. It has to look like that. This goes back to before they had calculators, and when you're dividing by 2 would be a lot easier than dividing by the square root of 3. So let's say that's flipped around. 2 divided by the square root of 3. So this is a decimal. This is a really long decimal, and they were trying to figure out how many times does that decimal go into 2. Okay? So instead of doing 2 divided by the square root of 3, that would be the square root of 3 outside going into 2. Okay, and that's a decimal that goes on forever going into a finite number. They would take top and bottom times the denominator. So they multiply top and bottom times the denominator. So here we're multiplying by 1. Root 3 over root 3 is 1. We're multiplying by 1, except it's just written as root 3 over root 3. So on top, we get 2 root 3. 2 times the square root of 3. Now on bottom, root 3 times root 3. Here's the rule. There cannot be purple when you're multiplying with radicals. 2 and root 3. 2 is outside, it's red. 3 is inside, it's blue. Red and blue, when you mix them, you get purple. Okay, it's kind of like your junior high dance rules. Boys are blue, girls are red. We don't want to see purple. Leave room for Jesus in there. Okay, so 2 times the square root of 3 is written as 2 root 3. Root 3 times root 3 is written as the square root of 9, which is 3. A square root times itself equals that number. So rationalize, this is what the answer would be, 2 root 3 over 3. It's just the shortest way to say it is put the square root on top and take the house off the bottom. Okay? Put the square root up top, take the house off the bottom. Okay, we'll see that here. We'll do some practice with that. You know, Mrs. Sattler's done something here. Okay, never mind. I'll get to that later. We're not going to do anything with variables right now. We'll tell you variables are divided by the index. So if you have a square root, it would be 2. So this would be 9g cubed root 2, if you want to try to figure that one out. These are just like we did yesterday. So 4 times 6, 2 and 2, 2 and 3, that'd be 2 root 6. This has a negative on the outside. This is 16 times 3, square root of 16 times square root of 3, or there's a pair of 4's right there. It'd be negative 4 root 3. Okay. Nothing with the variables that we're doing. Square root of 25 over square root of 64. So that's the square root of 25 over the square root of 64. So that'd be 5/8. That's it. Just 5/8. Take the square root of the top, square root of the bottom. Okay. This one, a negative, we have square root of 6 over square root of 49. Square root of 6, we check, can we simplify it? And we're like, okay, 6 is just 2 and 3. There's not any pairs of numbers in 6, so no, we can't. So square root of 49 is 7, so it'd be negative root 6 over 7. Okay, that'd be negative 14 over r squared. These variables you won't be seeing. 7x root x over 8y. See if you can figure that one out. There's probably actually an absolute value on there also. Cube roots, we won't ever see that. Okay. When you're doing cube roots, you're looking for sets of 3. So 729 divided by 3 is 3 and 243. Divide that by 3. That's 3 and 81. That's 9 and 9. That's 3, 3, 3, 3. So we have a set of 3s and we have another set of 3s, not the 9s. So 3 times 3 is 9. Cube root of 729 is 9. Okay, let's keep going here. Square root of 15 over 500. Okay, now neither of those are perfect squares, but we don't want to just jump to multiplying top and bottom times the square root of 500. Let's back this out a little bit and reduce the fraction. Reduce the fraction. So 15 over 500, you can divide by 5, and you get the square root of 3 over 100. So now, split it up, square root of 3 over square root of 100, that is root 3 over 10. Okay, so always see if you can reduce it. Square root of 8 over 100, again, 100 is perfect, but you notice 8 and 100, you can reduce that. I would divide by 4, so you get the square root of 2 over 25. So that would be the square root of 2 over the square root of 25, which is 5. Square root of 2 over square root of 25. Again, if you do it the way it is, you get square root of 8, square root of 100. So that's square root of 8 over 10, which looks like it should be okay, but the square root of 8 you can reduce into 2 root 2. There's a set of 2's and another 2 left over there. And so you get root 2 over 5 that way. Okay, the 2 and the 10 you can reduce like that. Okay, 15 and 16, none of those you'll see anything like that. Okay, adding, subtracting. Okay, so 3 root 8. How we handle this? 3 root 8. You got to simplify this part right here. The 3 is going to chill on the outside. So I got 3 times square root of 8 is 2 root 2. Okay, so square root of 8, 4 and 2, 2 and 2. So there's a pair of 2's with 2 left over. So 3 times 2 root 2, these two things multiply right there. So 6 root 2 plus 3 root 2. Because this is 3 times the square root of 8. So now it becomes 3 times 2 times root 2. It's all multiplication. You're using the associative property to group the 3 and the 2 together. So you get 9 root 2 for that answer. Okay, so all of these, you need to break these down first. So this is 2 times 3 root 2, 5 and 4, 2 and 2, minus 2 times 2 root 5, minus 2 root 5. So I get 6 root 2 minus 4 root 5 minus 2 root 5. So these right here, those are the ones that go together. So I get 6 root 2 minus 6 root 5. That'd be the answer. Okay, square root of 12, that's 4 times 3, so that'd be 3 times 2 root 3, 9 and 2, so plus 3 times 3 root 2. And that's 9 and 3, plus 2 times 3 root 3. So 6 root 3 plus 9 root 2 plus 6 root 3. So I get 12 root 3 plus 9 root 2. Okay, the multiplication ones here at the end, I don't think you have any of those. What you'd have to do with that is when you distribute, you just multiply the parts that are uncommon. So 2 root 5 times root 6 is 2 root 30. 2 root 5 times 2, now you take the 2's on the outside, that is 4 root 5. So you just multiply the parts that are common. Okay, these you would have to FOIL. You should get 4 on that one, actually. You try FOILing that out, you should end up with 4. So, a few more examples with the fractions. This one right here, 5 over root 5. Again, this is where you cannot back this out at all because this is a 5, this is the square root of 5. So we're going to take top and bottom times the square root of 5. And you get 5 root 5 over the square root of 25, which is 5 root 5 over 5. Now those cancel and you just get square root of 5. Okay, so look at those steps so you make sure you can see where everything came from. If not, email me. So 2 root 7, take top bottom times the square root of 7. So we get 2 root 7 over square root of 49, which is 2 root 7 over 7. 2 and 7 don't reduce, we leave it like that. Okay, square root of 6 over square root of 32, back that out. Square root of 6 over 32. 2 goes in there, so that's the square root of 3 over 16. So square root of 3 is root 3, square root of 16 is 4. So root 3 over 4. Okay. Square root of 3 over 24. So that's the square root of 1 over 8. That's the square root of 1 over the square root of 8. Now again, square root of 8, we've seen that. That's 1 over 2 root 2. Take top and bottom times the square root of 2. And you're going to end up with root 2 over 2 times the square root of 4, which is root 2 over 2 times 2, which is root 2 over 4. A lot of steps there. Okay, root 2 over 4, you do not reduce that because the 2 is inside, the 4 is outside. Okay, square root of 8 over 12. Reduce 8 over 12. That'd be the square root of, divide by 4, so square root of 2 over the square root of 3. Take top and bottom times the square root of 3. The 2 and 3 are both inside, so it's square root of 6. That would be over 3. Root 3 times root 3 is the square root of 9, which is 3. Square root of 10 over 60, that would be square root of 1 over the square root of 6. Top and bottom times the square root of 6, and you get root 6 over 6. Okay, leave it just like that. So, good job. Let me know. I know this goes pretty quick here. It's a lot of math. Again, if you have one of these calculators, that helps out. Make sure it's the Casio. But good luck. Let me know what questions you have, and I'll see you shortly, actually. So, see you soon. Miss you all.